This is the topsoil on which our life depends. It is the end result of the first three links in the chain of life. Nature's raw materials, the sun's energy, the chlorophyll in the plants. Although plants and animals are supported by topsoil, they also depend upon each other. Furthermore, their well-being depends upon the organization and balance of the entire living community. That community is made up not only of the plants and animals themselves, but also their environments, soil and water. We are now going to see how this community is organized and how each member contributes to the whole. Our story begins with a succession of stages, a story of endless change and competition. In a marsh, we find plants like water lilies growing in fairly deep water. Through the ages, they die and add their substance to the bottom, which rises, until shallow water plants like the pickerel weed and maiden cane grass get a foothold and crowd out the lilies. These plants in their turn add to the mire until in some places it rises above the surface. And now the giant pitcher plant gets a footing at the water's edge. The cypress trees, too, grow in the now shallow water. They die and fill the water. Birds and wind bring in the seeds of other forest plants. And trees better adapted to drier ground come in to crowd the cypress out. Here a bay tree forces its way up through the cypress. It is one of the so-called climax species that form the permanent forest. From a water lily to a forest, each plant in turn having played its part in building a coordinated community. But these developments could never have taken place without the services of insects and other creatures to keep the community in a working balance. This caterpillar, for instance, eating a leaf, will soon become a butterfly to carry pollen to fertilize the blossom, so making life possible for the plant. In feeding the caterpillar, the plant is raising its own caretaker. In fertilizing the plant, the butterfly is providing its own food. But these insects, unless controlled, would multiply enormously and kill off the very plants that feed them. So nature must strike a balance. Now the multiplying insects furnish an increasing food supply for predators and parasites, for insects, birds, and other creatures. Animals like this white-footed mouse eating an insect cocoon. But these controlling animals will in their turn increase until their appetites outrun the multiplying insects. So once again, nature takes a hand, and other predators like hawks and owls in turn control them. So to prosper, nature must achieve a balance. And upon the perfection of this balance depends the amount of life the land and water can support. For these same principles of interdependence also apply to life in the water. These are bream. Their existence depends on microscopic plants and animals called plankton. But plankton can live only in clear water that admits sunlight. Silt washing off eroded hillsides fouls the rivers and the lakes they feed. So in the final analysis, the welfare of the bream in the pond depends upon the condition of the surrounding land. If there are many water birds around the pond, their droppings will fertilize the water, increasing its capacity to raise plankton upon which the fish feed. But these well-fed bream are in danger. They are increasing beyond the capacity of the pond to support them. However, the introduction of the right proportion of predatory fish like bass will keep them within the limits of their food supply. As the bass increase, fishermen may catch the surplus, thus helping to maintain the balance. But they must always leave enough bass to hold the bream in check. For the bream eat the bass eggs, and if they eat too many, the bass will slowly disappear, and then again the bream must starve. The top bass here is 1 year old. The one beneath is 2 years old. Yet the top bass weighs 16 times as much. He was raised in a properly balanced, fertilized pond. The same basic principles of interdependence reach down into the soil. As this grain of corn puts forth roots, it is actually building the soil's elements into new and useful combinations. In much the same way, minerals have been made available in useful combinations by living forms of the past, and their work recorded in fossils such as these. When man takes his bountiful crops off the land, he is actually robbing the soil of these hidden values, which have been gradually built up through the ages by other forms of life. We can sometimes replenish the soil by adding proper fertilizer. But the minerals we dig up for this purpose cost our farmers millions of dollars each year. They may help keep our worn-out lands productive, but we pay for it in higher food prices. And those who can't pay in dollars must pay in other ways: hard work, hunger, and poor health. For if the soil lacks certain balanced qualities, it cannot give its crops the power to raise healthy people and animals. These cows are eating what appears to be perfectly good grass. Actually, they are starving. They starve because this soil lacks one single element, cobalt, essential to their well-being. At the University of Missouri, Dr. William Albrecht tried raising hay on 3 plots of soil. To one, he gave no fertilizer. The next, he fertilized with nitrate of soda, and this produced nearly twice as much hay per acre. But when fed to rabbits, a pound of this nitrogen-fed hay produced less meat than a pound of the small, unfertilized hay. To his 3rd plot, he added all the important minerals that the crop needed. This plot produced less hay than the nitrogen-fed plot. But each pound of this hay produced nearly twice as much meat as the much bigger nitrogen-fed crop. In another test, 2 lots of hay were raised, one on soil deficient in lime, the other receiving plenty of lime. Rabbits fed on the lime-deficient hay produced no young. Those on the well-limed hay raised normal families. Then the hay food was switched. The formerly productive rabbits raised no more young, while the formerly unproductive rabbits now began to raise normal families. The quality of the animals obviously depended on the quality of the soil. Now we see the true meaning and need for conservation. In order to prosper, nature must achieve a balanced community, and upon the perfection of this balance depends the amount of life that the land or water can support. In other words, the carrying capacity of the land. Only so long as we work in harmony with nature's laws may we continue to reap a bountiful harvest. Who shall have the right to disregard these laws? Who shall have the right to misuse this vital earth?